Hello guys, welcome to the lecture 3 of our Gemini Code Assist course, and in this video what we'll discussing first is an expense tracker web app, which is what we're building using the Gemini. In the last video we actually installed Gemini in our CLI. Okay, so now we're going to talk about in this video that what the app will be and what will be our strategy and all those things. From the next videos onwards we'll start developing this app. Okay, we'll also talk about why we are building this app. We'll talk about the MVP features that we'll implement in this app. MVP, you know, right? This is a minimum viable product. It's a very simple kind of a app, and that is what we're going to build. Then we'll talk about a tech stack that we're going to be using and what will be our development strategy to build this app using the Gemini Code Assist, both the IDE and the CLI. Okay, now let's understand our goal is we are going to be building a data-driven expense tracker web app from scratch using Gemini CLI. We'll show how Gemini supports the full stack workflow, that is basically the UI, the logic, and also the databases as well. The focus for this development of the app is to do rapid prototyping using the AI assistants. AI assistants is basically the Gemini Code Assist, and what tools we have with it is the extension and the CLI. Okay. Why are we building it? Let's try to build some story around this, like why we are building this app. So for example, what has happened, and usually what happens in teams or companies is that a team has been like tracking expenses in a sheet. Okay, they saw some problems while tracking these expenses in the sheet is that the categories are not consistent, like food, travel, and sheet. It doesn't give you a feel of an app or like a website, but it's more like a sheet, right? So that's why inconsistent categories, like which category you want to create it for an expense for food or utilities or whatnot. No clearly monthly summaries. I mean, you need to have Excel expertise in order to see or calculate all those monthly reports and all, and difficult to see the spending trends as well, right? So these are some of the issues that if you are as a team are tracking expenses in a sheet. As a result, budgeting decisions are harder and errors creep in. So basically the team was not able to manage all those expenses in the sheet. So they decided to build a small, ask their team lead to, hey, go and build a small app where we can track all the expenses. Okay. So that's why the team lead requests a simple web app to organize and visualize expenses. So we'll try to develop this MVP for them. Okay. Now, what are the MVP features that we're going to do in the MVP, or basically in the what we can call this product as like minimally viable? It should have these features, right? It should have one expense model. The expense model, basically it will have an ID, it will have a title, it will have a description, and every expense will have an amount that how much this expense could cost, it has cost me. Then category like food, travel, or utilities. Basically, we'll be covering these three categories only and not more than that, right? We'll talk about expense date, right? One expense date is one of the field in this model, which basically tells when did this expense actually happen. Created at, it is like one of those date kind of a thing where we say that this is the time when this expense was added in our database. And then updated at whenever the expense, this entry in the database is updated, so this updated at will change. Okay, so this is how you generally define a model, and model is basically nothing but describing your main object in the program. In this case, we are only tracking the expenses, so my main object is, or basically my main thing is here is an expense, one expense, right? The core functions that we want to support is basically CRUD on these expenses. CRUD basically means create, read, update, and delete, right? So we can add a new expense, we can view all the expenses, we can edit or update an expense, and we should be able to delete an expense. That's it. Okay. Then what we need a dashboard whenever client opens or whenever anyone member in the team opens this URL. So what should happen is all the expenses should be there in the dashboard, kind of a not all the expenses, but kind of a cumulative view of all those expenses, maybe totals, or should be allow some filtering by categories and all those things. This is what if we do in the MVP, then it will be kind of an the team will accept it. Okay, now let's talk about a tech stack that we are going to be doing in this project. One is the Flask. Flask is basically for lightweight web development. Flask is generally written in Python, and it's basically a very simple framework for developing web applications. We'll be using SQLite as database and SQLAlchemy as an ORM. ORM is basically your object relational mapping. Basically what it means is I can write something like this in Python, expense.create, right? And this will be translated to a raw query in the database. Raw query is basically create expense item in expense table. This is a raw query, right? But in Python, you can just write like this and it will do your job. It will do your job of converting that into a row query and inserting that entry into the table. Okay, so this is what ORM means, and SQLAlchemy is just one of those ORM library that does this for us. Okay, and we'll also do some testing using Pytest to ensure the reliability. So we'll write some test also. We will not write some test. We'll only do natural language communication with the Gemini, and it will write the tests for us. Okay, now let me give you a quick small example of what does our architecture look like. So for example, let's say our client opens this URL in the browser, expensetracker.in. And in this URL is where my Flask server is kind of hosted. Okay, and this is kind of the client has opened the URL in the browser. So it's a GET request to the server. Okay, so at this GET request, the job of the Flask server is to return all the expenses back to the client. Okay, so what happens when the request is reached to the server basically checks that what route this request has reached to me and what type of request has reached to me. So the server will see it is a GET request at the root route. So it will try to get all the bugs, and basically you have written some Pythonic code here to handle this request on this route. It queries the database using SQLAlchemy, which is basically my ORM, right? Basically fetch all the expenses kind of a thing. And it will make this query, this thing will be converted to raw query to the database, and it will return in response all the expenses that has been added for this client. Okay, and then finally from here we'll return all the expenses. And then what does Flask server does once it gets all the data from the database around the expenses? What it does is it has a template, right? The template is basically the HTML code, and in the HTML code also you can just put all these expenses inside the template. Okay, and then finally the final HTML is kind of returned to the client, and the client job is only just to render that HTML. Okay, and also the CSS files and all those JS files, what it happens is inside this HTML it kind of has the links to those CSS file. Okay, so when this HTML is reached to the client, what happens is it sees, hey, where is the CSS file? So it gets the link from inside the HTML, and then it makes a request for those files to the Flask server again. Okay, so this is how the overall workflow happens. I've just explained it in a very simple term and not complicating about like authentication and all those kinds of stuff. Okay, now let's talk about a development strategy. We will use a prompt first approach with Gemini, right? We will provide all those requirements that we want to build this in natural language to our Gemini CLI. Gemini, what it will do, it will scaffold the Flask project for us, the expense model and CRUD routes. Developers like us who will be working with Gemini, providing requirements in natural language and all those things, will also kind of refine those things again and again. Sometimes we will not be sure about the output that we are getting. We are not satisfied with the output that we are getting from the Gemini CLI. We'll keep on repeating it, right? And then we'll also add more and more improvements so that we get what we actually want. Okay. And finally, we will have a functional expense tracker web app with clean design, built faster by combining developer experience with Gemini's automation. This is the result, and this is the app that we are building, and this is what we should be ending up with. Okay, so that's it for this video. This was a very theoretical video, and I hope that you must have installed these two things. One is our Gemini Code Assist extension in the VS Code, and the other one is going to the terminal, and let me quit this, and we installed this Gemini in our CLI, right? In our terminal we have installed this CLI as well. In the next video we'll go and set up this Gemini CLI in our system, and we'll see how we can make this some request to the Gemini server and kind of get the code output that we want from that. Okay, so that is it for this video, guys, and I'll see you soon. Bye.